Right, so we're gonna put this all together. And talk about the important ideas. So the first one is that slope fields are a graphical representation of a differential equation that allow us to visualize the family of solution curves. So if we're looking at the slope field we just drew here, you can tell that the family of solution curves is going to be parabolas. As I follow the trend of all of these slopes, every time it forms a parabola. And that's what slope fields allow us to do. All right. So whenever we are making a slope field, what you'll do is calculate the slope at various ordered pairs. And then you're just going to plot those little baby slopes. So plot the slopes using short line segments. All right. And then a solution curve will follow the trend of the slopes and must pass through an initial condition. So if you're given an initial condition, just make sure that your solution curve will go through that initial conditioning and follow the trend of the slopes. All right. And then if dy over dx is undefined, do not draw a slope there. Just leave that point with no slope, no little segment, because it would be undefined. All right, so we are going to draw a slope field for each differential equation. And then on these little dots, each little tick mark represents 1. So as we go out, that's 1 unit to the right, that's 1 unit up. All right, so we need to know that, so we'll plug in the right values. Okay, so for the first one, dy over dx is negative y. So if I just start at the top left, that's the point -3, 2. And for this differential equation, we only have to plug in the y. So we only have to plug in the 2. So when I plug in the y coordinate there, I get -2. And so I'm going to use my ruler. You do not have to use a ruler every time, but that's down to right 1. So it's just a little slope of -2. Okay. Now if I go to the next point to the right, that's the point -2, 2. So I'm still just plugging in the y. So I'm still plugging in 2, and I'm going to get -2 there. Okay. So as I go, all of these, well, it's not good. All of these to the right of that horizontal line, all have the same slope, slopes of -2. Now the one we did here only had an x. And when there's only an x, the vertical slopes are all going to be congruent. Okay, so let's go to the next row. This one I didn't draw great. It should be more steep. Anyway, this is the point -3, 1. I'm only plugging in the y. So this should have a slope of 1. So it should look about like that. And then all of these to the left are going to follow that same slope because they all have a y of 1. And when you plug it in, you get -1. And then the next point down would be -3, 0. When I put 0 in, there's no -0, so those are all little horizontal slopes of 0. Okay. And then the next point here is the point -3, -1. When I put that in, I get 1. So I've kind of marked through all of my little dots, but a slope of 1 is about like that. All right, and then as you go over, just do the same little slope of 1. Okay, and then this one, this is the point -3, -2. When you put -2 in for the y, you get +2, which should be about this slope, right? And then just follow that as you go over to the right. All right. So if there's only a y, horizontally the slope's equal. If there's only an x, vertically the slope's equal. Let's see what happens when there is an x and a y. So on these, we'll take each of these ordered pairs and we're going to take the x coordinate and divide it by the y coordinate. All right. So for this first one, to the left, the x is -3, the y is 2. So that's going to be a slope of -3 halves. All right. So at this point, I want to go down 3, right 2. About right there. Down 3, right 2. And there's my little slope. Okay. Okay, for the next, I'm just going to go to the right. You can go down or right, whatever you want to do. I'm going to go to the right. So that's the point -2, 2. So I'm going to take -2 and divide it by 2. I get a slope of -1. That's about right there. All right. Then I have -1, 2. So that's the slope of -1/2. So that's down 1, right 2. All right, when I get to this point here, I have 0 divided by 2. So that's going to be 0. So it's a little horizontal slope. All right, this point is 1 divided by 2. So that's going to be a positive 1/2. So if I go from this point to this one, it's up 1, right 2. All right, this one is 2, 2. So we divide those, and it's a slope of 1. All right, and then this one is 3, 2. So it's a slope of 3 halves. So that's going to mean up 3, right 2. Sorry, it's taking me a second. So here's the point. 1, 2, 3, 1, 2. All right, that's our slope. All right, so those definitely aren't equal. Let's see what happens vertically. All right, so this point right here is -3, 2. Sorry, -3, 1. So that's the slope of -3. So at that point, I need to go up. Sorry, I need to go down 3, right 1. Slope right there. All right, this is the point -2, 1. So a slope of -2. So from this one to this one, it's down 2, right 1. All right, and then -1, 1 is going to be a slope of -1. All right, and then 0 divided by 1 is 0. All right, and then this one would be 1 divided by 1, so a slope of 1. This one is going to be this is going to be 2 divided by 1, so a slope of 2. Okay, and this one is going to be 3 divided by 1, so a slope of 3. I don't really want you guys to get too hung up on drawing your slopes perfectly. It is just an estimation. On the AP test, you cannot use a ruler. So I'm just trying to make it neat for you all. But you don't have to use a ruler to do this. All right, so then this next one, next row, this is the point 3, 0. So take 3 and divide it by 0. That's undefined. So there's no point there. This is 2 divided by 0. None of those are going to work. The whole x-axis is going to be left blank. This differential equation is undefined there. All right, and then this one is -3, -1. So -3 divided by -1 is +3. So it's hard to see where those dots were. That's okay though. So up 3, right 1. So -2 divided by -1, so slope 2. 1 divided by 1 is the slope of 1. Negative 1 divided by negative 1, I should say. All right, and then negative 1 divided by 0. I'm sorry, 0 divided by negative 1 is 0. All right, this one should be 1 divided by negative 1, so that's the slope of negative 1. 2 divided by negative 1 is the slope of negative 2. And then 3 divided by negative 1 is the slope of negative 3. So I'm just going to estimate it. Getting steeper as you go out. All right, one more row. So this point here is negative 3, negative 2. So negative 3 divided by negative 2 is positive 3/2. So up 3, right. 2 would be about right here. All right, and then we have negative 2 divided by negative 2 is positive 1. All right, and then negative 1 divided by negative 2 is positive 1/2. And we get 0 again, and we get 1/2, negative 1/2, negative 1, negative 2. All right, so we don't have equal slopes there. Sometimes on these with x's and y's, the diagonals are equal. So this diagonal should all be 1. This one should all be negative 1. So sometimes you do see that, but not always. All right, so that's doing slope fields. For 2, we want to sketch a particular solution to this one that we did right here that passes through the point 0, negative 1. So 0, negative 1 is right here. So we want to go through that point, and we want to follow the trends of the slopes. So as we go to the left, it looks like we're trending downward, and it gets steeper. As we go to the right, it's going flatter. So that would be that solution to that particular point. Right, and then for number 3, we have a slope field. This is a slope field, and we want to figure out which equation would have that slope field. So not which differential equation would have it, it's like which equation would follow this trend. All right, so we need to know what those graphs look like. So e to the x is an exponential graph that's flat and then curves up. Like, to me, that doesn't look like that. All right, we all know x squared is a parabola, and to me, it doesn't look like a parabola either. So if we just kind of picked a place and we started drawing, it kind of follows that trend. It's curvy, which that's actually what natural log looks like. All right, and then sine is that, and it's definitely not that. So the closest one to what that looks like when we follow the trends of the curves is going to be the natural log. All right, and then for 4's got some work to do. So we're going to let y equal f of x be a particular solution for this differential equation, satisfying that f of 3 is 4. We're going to write an equation for the line tangent to it, and then we're going to use that to approximate f of 3.1. So this is using some old stuff that we haven't really talked about in a while. But I think you guys remember, hopefully, to write a tangent line, you need 2 things. You need the point of tangent C, and you need the slope of tangent C. All right, now we're given the point. It tells us right here, the point 3, 4 is your point of tangent C. And a differential equation is an equation of slopes. And so if we want to find the slope of the tangent line, we just take this differential equation, plug in our point of tangency, and it gives us the slope. So this is telling us to find the slope, we're going to take 3 and put it in for the x, and take 4 and put it in for y. So we have our slope. All right, So finally, we can do our tangent line by using the old point slope. So it's y minus the y part of the point of tangency times the slope, or equals the slope, times x minus the x part. Okay. And then if we want to find, we use this tangent line to approximate the value of f of 3.1. What we would do is we would just take our 3.1 and put it in for x. Now, if we're working with decimals there, I'm going to go ahead and work with decimals for my slope too. All right, so it's going to be y minus 4 is equal to 0.75 times. Now, 3.1 minus 3 is just 0.1. Okay. Now, when I multiply, sorry, this should be minus. When I multiply anything by 0.1, it moves the decimal point over 1 to the left. All right, and then when I add 4 to that, I get 4.075. So that would mean that f of 3.1 is approximately 4.075. So that's some old math we haven't done in a while. All right, so your assignment is to do the slope field packet. There's quite a bit on here. So the front is just drawing some slope fields. So plugging in the points for x and the y and drawing your little slope. So don't forget that when your differential equation only has x, that means the vertical points are going to have equal slopes. So that's what I mean. I worded that kind of weird. It's hard to word that. That's like this one right here, where as you go down each vertical line, the slopes are equal. All right, then if it only has, y, then the horizontal points will have equal slopes. And that's like the one we did here. So as we went horizontally, all the slopes are equal. All right, so that's drawing the slope field, just super fun. All right, this one is kind of like that number 3 we did, where we're picking out what function follows that trend of the slope fields. So like this is a horizontal line, so you look in here and see like which slope field gives you a horizontal line. This is going to be a diagonal line, and you just go through that. Now, if you're not sure what a function looks like 11, you might not know what that looks like. Just look at it in the calculator and see which one follows that trend. Or 14, you might need to look up too, or you maybe could figure it out on your own. All right, and then this one is different. This one is match the differential equation with its slope field. So this means if I put in the point 0, 0, this gives me the slope of whatever line is drawn there. All right, so I would kind of use this idea here to help me figure that out, because if one only has an x, as you go down the rows, the slope should be equal, and so you could pick that out. This one only has a y, so as you go across, the slopes would be equal, so you should be able to pick that out. Okay, and then then you have a couple where you're drawing the solution curve through a particular point, just following the trends. That is something they put on the AP test, drawing the curve that follows the trends. And then the back is like example 4.